All right, welcome again. We got a noisy house here, but I'm going to try and get through the last chapter of the Essential Mathematics for Computational Design, 4th edition by Raya Isa. And I think it ends with why scripting back into the Python nodes or C# or VB is essential to learn. And so hopefully I can make some sense of that. Basically, I'm going to go in to the script and show you, put this on here, that we deal with some points, we deal with some secondary points sets. We're going to build a NURBS curve through it, and I think just for convenience, I'm going to bring up my bifocal tool. So you're going to bring in two sets of NURBS curves here and here, and we're going to reparameterize those curves, each of them, and we're going to take them into a couple things just to start. I'm going to ignore the VB and C+ scripts because that's something I'm not interested in learning right now, even though I've been through a couple of solo learn things on C#. I think it's best to just stay with Python for myself. I'm basically finding beginning and end point to these curves. So as I stay on here, these are some simple scripts, and I've downloaded this from what they offer free online. You can see that I'm starting to locate the end of that one and the first part of that part and see, are they equal? And the answer is true. So that's the first kind of script that'll go in the Python. The derivatives is an interesting tool that you take this curve and this curve, and I'll go back into them, and find the derivative of that curve, which is at that point, and the derivative of that curve, which is at that point. And derivatives themselves evaluate the derivatives at a curve at a specific parameter. So, parameter. So that parameter is being set at 1 and 0 in those two scripts. They do a great job of organizing this. You can then end up taking a look at the vectors that come off tangential on both those points. You see a subtle difference between the two of them. Dot product is something you're going to want to go into and start using, and really the whole study of this whole book is to get you thinking dot product, cross product, and how they apply through vectors, through matrices, and into actual NURBS surface curves and NURBS surfaces. You really have to read the chapter, and after going through Ron Cheng's book a couple of times, obviously I realized the essential of that, because without being able to build curves and proper, you won't be able to make any cool surfaces afterwards. Dot product's going to test again for equality in a sense, and you're going to play with this strange pattern of finding out if it's a G0, a G1, or a G2 continuity. And this one's going to test it through this kind of script of gates as it moves through and find out that it's a G0 continuity for these two curves that I have out here available to me. And even though I did have it set at G2 earlier on, I believe I've done something to the script that brings it back into a G1 continuity. So not sure really what I did to it, but I did something to it and changed that so it went back to a G0. That said, the last part of the script is dealing with finding the curvature of those things, which generates a circle and a secondary circle, and you have to pan back to see how the curves relate to those as you go back into the first curve and the second curve, which are very, very tiny at this point, so it's hard to see the curvature along the lines of those. They're amplifying it quite a bit in a sense, and even though the curvature, and I've got it on full display, let me jump into here and go into display full names. Display full names should allow us, it's going to script the script a little bit, but you see what's happening. An amplification as we move through the vector into that direction, and then another dot product coming out of this section. And sorry, it's kind of jammed up right now. Test for equality again, and you move through and you find out what continuity is associated with that. So you're going to go through chapter 3, read all you can through curve surfaces, curve parameters, and basically that's what you're doing in the final tutorials, is testing for continuity between curves in the sense of what I've said, G0, G1, or G2. I'm going to take that whole script, which is there, pretty big, and I'm going to put it on disable for now. And then the last script they bring in, and they put it through VB and C# and Python, I'm going to jump in there and just do the Python script for a sphere. So definitely I have to leave this nightmare of everything else. Let me isolate this and jump right back to the sphere in the center of the page. And I generated a cone. And I have a radius of 1, a radius 1.5, and the length 2. So I can actually have these two. And this script is fairly interesting. If I bring him here, I've got my sphere, and my Python script is going to check for singular points. And they do not give an example of doing this node-based because maybe it's not possible node-based. So when you click in here and you go onto your Python script, which is pretty interesting, you'll see that this is the script that's essential, very short, but for generating those singular points, which are referenced here as 0, 0, -1, 0, 0, 1, and 0, 0, 2. And I guess this is kind of critical in my learning that I've realized, yeah, I've understood Grasshopper pretty well for the last year. I've gone into it. I've tried to get through all the nodes, but at some point, I'm going to have to go in this script, and it's a nice example of what's happening. Declare a new list, which is not hard. Build a variable, make a blank list. Examine the trims, which is a function of going into the surface for trim in surface trims. Find all the null edges of the trim. Indicates any null edge indicates if it's singular or not. And if trim edge is set equal to none, then you're finding the 2D parameter surface point at the trim start or end. And that's basically what that geometry ends up doing. So when we go into it, we find within that sphere, if I could just move this out of the way a little bit, we find within that sphere and that cone where those points of singularity are. And they're kind of hard to see here. So I'm just going to leave it visible on everything. And there are the points of singularity. And they make a lot of sense within those geometries. That said, we'll stay to the Python script, having a little deeper look into it. The point 2D trim is going to be point at start. Point 3D trim is going to be point at point 2D dot x, attribute to x, and point 2D at y. So in the end, you append the list and you end up with A as the output, and you've got your singular points, and that's just adding 1, 2, 3 points to it. If that's not really making sense to you, then you're not shifting really into Python in your thinking. There are examples here that if I double-clicked on C, I'm going to get a totally different type of script of how to write that, which I don't really, it looks like a pretty simple script writing again. And what I like about C is it's always contained within these kind of functions, curly brackets, and you know when you begin and end those scripts. You just have to set them up right and declare all your variables and proper to what they are, which Python kind of does for you. And VB script I haven't spent too much time on at all, which was there before, but it actually looks like it's quite understandable if you want to take that. And I guess those are for people that were dealing with Rhino a lot earlier than me, late 2018 when I got into this. But I like that kind of script because it relates to Python a little bit more readability for me. Hope that helps in any way get you started on this, but I would definitely recommend going into the services. Going into the tutorials, you're going to pull 3 out of the vectors chapter 1. You're going to pull a couple out of the matrices chapter 2, which will get you to understand matrices and transformation matrices, how to control geometries in a much more condensed and confined scripting realm. And then the last chapter is going to get you really rethinking what control points are, knots, weights to control curves, and actually build what really clicked is I started to understand what the non-uniform meant in rational B-splines. Really was a sense of weighting things differently. So I like to think that I'm getting a little smarter doing this and not just getting lost farther down in the woods. Pretty exciting to figure out. I hope everybody enjoys it. I'm finding a community. I've got a couple hundred followers. I think serious people that are interested in the seriousness of what I'm doing. And hopefully I can apply this back into sculpture, and after 20, 30 years of making it and teaching 2 decades at the Kansas City Art Institute. Thanks very much.